Take a look at the phone in your hand. You tap an app icon, and a feed of posts, photos, and messages instantly materializes on the screen. But that immediate feedback is an illusion. Your device doesn't actually hold that data. Instead, a microscopic pulse of light shoots from your phone, crossing thousands of miles of fiber optic cable to reach a remote server. Bridging this immense physical gap is an incredible engineering challenge. You have millions of different devices, smartphones, laptops, smart TVs, all trying to communicate with completely different servers. To prevent total chaos, they need a strict, universal set of rules. That rulebook is called HTTP, or Hypertext Transfer Protocol. It is the workhorse of the web, ensuring that no matter who makes your phone or where a server is located, they speak exactly the same language. Every time you pull down to refresh a feed, upload a photo, or send a text message, you are kicking off a highly choreographed HTTP transaction. Grasping exactly how this transaction works reveals how the digital world scales reliably to billions of users without collapsing under its own weight. The most important rule of HTTP is that it is strictly client-initiated. Your phone is the client, and the server never speaks unless spoken to first. The client has to ask for everything. To ask for something, the client starts with a verb, like post, paired with a destination path. Next, it packages the data into the request's body, formatted in JSON, a lightweight text structure easy for machines to read. But HTTP is stateless. The server instantly forgets who you are after a transaction. So the client adds a header section containing a secure authorization token, like an ID badge akin to an envelope. Relying on this encrypted token means you don't pack your username, password, and profile details into every single request. Multiplying those saved bytes across millions of daily actions saves a massive amount of network bandwidth. The completed HTTP request launches into the network, carrying the instructions, data, and proof of identity all in one shot. Because these requests are completely self-contained, the backend server doesn't have to keep millions of user sessions actively open in its memory. It just reads the packet, does the work, and moves on. When that package finally arrives at the backend server, the very first thing the system does is scan the authorization token to confirm the user is allowed to be there. Once the badge clears, the server opens the payload and executes the core business logic. If you are using a chat app, it takes your text string and securely writes that new message into the main database. The server replies with a 3-digit status code, 200s for success, 400s for client mistakes, and 500s for server crashes. If successful, it generates a 200 OK, which acts as a guaranteed receipt returning across the network to the client. Your phone's app intercepts that success code. Only then does it finalize the action, securely updating the local screen to show the message as delivered. This strict, closed-loop lifecycle ensures that your device and the server stay perfectly aligned. By demanding a receipt for every action, the system prevents phantom messages or glitches, where your screen shows something the database never actually received. HTTP is brilliant for discrete actions, but its stateless nature creates a hard functional limit. It cannot efficiently handle continuous real-time listening. Look at this diagram of a continuous polling loop. If you tried to build a live typing indicator using HTTP, your phone would have to repeatedly ask the server, "Are they typing yet?" over and over, wasting bandwidth on empty responses. That is why modern applications use a hybrid architecture. They maintain an open, stateful connection, like a WebSocket, to stream constant live events down to your phone, separating the passive listening from the active doing. But for everything you actively do, sending a post, liking a photo, buying a stock, HTTP remains the undisputed tool for the job. It ensures the action is safely authorized, processed, and acknowledged. By treating every single action as an isolated, independent event, the backend doesn't have to juggle the active states of the people using it. That amnesiac simplicity is exactly what allows the modern internet to scale to billions of simultaneous users.